Okay, good morning. Welcome to another lecture in the course GeoPython. It's week 5, and today we are going to start working with real data, doing real analysis. Well, everything we have done has been real, but now it's getting more serious. Let's just still wait a couple of minutes. If you have some questions, comments from last week or previous weeks, you can put them to the poll, and we can go through them together. But at the same time, I can give you an introduction of what we are going to talk about. So from today on, we are going to start working with Pandas library. I have brought up the term and the concept a couple of times during the last weeks, but now we finally start working with them. And now we are prepared. During the last few weeks, we have acquired the skills that help us work with this library. So we have covered the basics of Python, so you have built some level of confidence in using this programming language, which is essential now that we are getting into more advanced topics. And also last week we started talking about libraries, like modules in Python and how to work with functions. And today we are going to start working with Pandas library, which will be the main library we will be working with during the coming weeks. So today we will cover the basics. You will know what Pandas library is about, what are some of the basic functionalities, like how do you import data, how do you export data, how can you manipulate data, explore your data a bit. And from next week we will get a bit more advanced, and on the last week you will learn how to use the same library to create different kinds of visualizations. So there is no comment here, which means everything is clear, which is good. So we can get started. There will be a lot of contents today. So I will be talking more than I usually do. So let's get started. I've already pulled the latest changes. So while I'm showing you the course's website, you can do that, get the latest changes. Then you should end up with a new L5 directory here. But yeah, lesson overview. As I said, we will start using Pandas, which is a modern and feature-rich data analysis framework for Python designed to make data analysis and manipulation straightforward and powerful. Our learning day goals for today: we will learn how to read and explore tabular data in Python using this library. We will do some simple analysis using this library and learn about data structures and functions that come within this package. And then, of course, we will learn how to also export our data, for example, in CSV format. So that's the agenda for today. And for many of you who have taken this course with the motivation to be able to do data analysis, now we are getting into that space. So a little bit about Pandas before we start working with it. So we all love Pandas, they're cute, but this library doesn't really have much to do with it except that the image appears in the logo. It is, I guess, short for panel data analysis or something. It was originally written by a smart guy called Wes McKinney, and he's also very active in Python community. So the idea was that, okay, Python was getting more and more popular for different fields of science, for data analysis, and the libraries that we had before that, they were powerful, but they were not super intuitive. So, for example, if some of you have worked with R or data analysis, you know that it's a bit more intuitive. You see the tables, everything, like the data comes in like this table format, two-dimensional. You can understand what it is like. But in Python, before this library, we were pretty much working in like one-dimensional space. So you were working with arrays, even if you were working with tabular data. And that makes things a bit less intuitive. So the idea of Pandas was that you build upon all the many possibilities that already existed in the world of Python. You just make it more intuitive and bring things into one package. So what Pandas is a high-level library, meaning that it is building upon a number of existing, well-known, powerful libraries. Later on, when you start creating your own Python environments, installing libraries, because now in this course everything is ready for you, you will see that when you install libraries, very often they come with dependencies. So it means that in order to install, for example, Pandas, you have to have a number of libraries installed. And they usually come in a package. So if you install Pandas, you will end up with NumPy, Matplotlib and a few other libraries. So it's a high-level library that is using other libraries to bring you functionalities. For example, as we will see in 2 weeks, if you're creating a plot with pandas, it just uses the functionalities provided by Matplotlib. So even if you're using pandas, like it's actually the Matplotlib that is doing the job. Yeah. So so one of the best things about it is that it uses easy to use data structures, and I'm going to talk about that shortly. It combines functionalities from many Python modules. As I mentioned, the very core of it is NumPy. NumPy is a very powerful module that is actually coming from C language. So it's very like core library for doing different kinds of data analysis and mathematical computations. But as I said, it's powerful. Many people use it, and we are using it within pandas, but it is less intuitive. So pandas is a bit better, or makes our life a bit easier in that way. There's also NumPy that we have previously seen for some mathematical calculations. There is Matplotlib for visualizing things. There is SciPy, which is also a powerful library for many different engineering tasks. Yeah, so another great thing about pandas is that it works with many data file formats. So if you want to import data, it's like there are a lot of file formats that are supported, many of which may not be even familiar to you. Might be useful or common in some other fields of science. So very often we get our data sets in Excel format, different kinds of spreadsheets. In CSV, you might get it from web in JSON format. It might be HTML. It can be, as I said, Excel. It can be Stata and Python pickle format. So there can be many formats, and there's a good chance that pandas just supports. So you don't need to do any conversion beforehand. You just use pandas to read the data, and it should work. It also works very nicely with database files. So like if you're working with PostGIS, PostgreSQL, or MySQL, different kinds of database formats, then it works nicely. So these are some of the good things about pandas, but now we get to learn more about it. So let's go to our NOPE environment, and I'm going to go to the L5 directory, and we start with pandas basics. Okay, so we already talked about part of this page, so we looked at the formats that are supported. One of the most important things about pandas to make your life easy in the long run is to understand the data formats. So this is a problem that you see many people have, those who haven't really taken a course in pandas or haven't systematically learned it, just tried like copying from somewhere, they have this confusion. So there are two types of data structures that we will be working with in pandas. So one of them is a data frame. The other one is series. So a pandas data frame and a pandas series. So what is the difference? A data frame is a table, so it's two-dimensional. So you have rows and columns. And then you have pandas series, which is one-dimensional. So it's just a row or just a column. So it's one-dimensional. So it can be a bit confusing if you just see the term without like reading the instructions. Because things you can do are a bit different. Some functions that work with data frames don't work with series, or vice versa. So let's look a bit more closely at the data formats. As I said, one of the great things about pandas is that the data structure is intuitive. So you see it like this, which is a format that you're comfortable with. It's like a spreadsheet. It's like how you would see things in Excel. So you have a first column that is called index. So it is built. When you import your data into pandas, it automatically creates a column called index. Even if the name doesn't appear, it's the index column. By default, it's similar to list indexing. So it starts from 0 all the way to n-1. But you can change the indexing, and we are going to see that, I guess, next week already. So by default, it's an integer. It starts from 0, but it doesn't have to be. You can change that. But yeah, that's indexing. Then you have your columns that come from the data. So the columns have a name. You have a column name that is column label that you can use find them or address them. Then you have, of course, your data that can come in different formats. It can be numbers, it can be text, it can be Boolean, it can be any kind of value that we have seen before. And yeah, and that's it. So if you look at a data frame is essentially made of data series. So each row is a data series, or each column in your data frame is series. So when we are going to see it already today, if you just isolate one row to look at or one column to look at, it essentially becomes a pandas series. So we have the same thing in series. Series are also indexed in a similar way, and they can have different data, and they can have different data format, and they can have a column label. For example, if you have isolated one column of your data frame, then you have the name for it as well. Yeah, so that's the main difference. Let's remember that. So some of you will be using pandas later on for doing GIS, whether on your own or if you're continuing to the second period course. There is another library that we will be working with in that course called GeoPandas. So it's just pandas. Everything that we learn now we are going to continue using. So it's another library, even higher level library that uses pandas and everything that comes with pandas, but also adds some geospatial functionalities. So there we talk about geodata frames and geoseries. So the difference is that you have a column with geometry, so you have coordinates. So, but it's otherwise very similar. So if you're continuing with GIS, what we learned with pandas is going to be very helpful to you later on as well. Yeah, so there are a lot of details about the data and things you can do. We cover many of them today, but also they have very good today and in coming weeks, but there are also good documentations available, and we have provided the link here. So if you want to learn more about pandas, or if you have a specific question about how you can work with a certain function, then check out the documentation. So do you have any questions so far? If not, we can get started with the practical part of our lesson. Okay, so as I said, we are going to use real data from this week on. So we have gotten the temperature data from the Finnish Meteorological Institute. So they have a very good portal. So if you want to play with things in Python or in your other courses, other projects, and you're just looking for free data, the FMI has a very good API. So if you want to get the data through API, they have a good API. But also they have a very good user interface. So if you are looking for data to try things out, they have great resources. So the data comes from there. We have changed the data. The data is real, but we have like formatted it a bit differently so that we can show you different things during the course. But yeah, that's where the data comes from. It is a data set of temperatures from summer 24, so it's last summer. Yeah, and this was an exceptionally hot summer. There were some Yle articles and some articles here and there telling that there were, in some days, some temperature records were broken. So we had very exceptionally hot days. That's why we updated the data for this lesson last year, motivated by that news article. But yeah, so it's a temperature from the summer. So it's from 1st of June all the way to the end of August. So it's 92 rows, 92 days, resulting in 92 rows of data. If you want to check out the data, it's under data folder here. So it's Kumpula summer temperatures or something, summer 2024. It's a TXT file, but the format is CSV. There's a screenshot of the data here. Probably you know what CSV is short for. CSV is comma separated data. So what it means is that the data in the values in your data set are separated with a comma. So that's the original definition of CSV, but CSV, even if it means comma separated, it can have different forms of separation. So it can be a colon, it can be semicolon, it still be called CSV file. So if you want to look at the data, you can even check it out from here. So this is what our data looks like. So we have some metadata at the beginning telling that, okay, it's who has prepared the data, what is the source of data, some information, what is temp 1, temp 2, As you can guess, this is information about the date, maximum, minimum, temp1, temp2, and the values are separated with a comma. So this is the data we'll be working with. So so if you check out the metadata, you will see that there's temp1. Max and min are the maximum, minimum temperatures of the day. Temp1 is temperature recorded at 10 a.m. and we have a temp2, temperature recorded at 2 p.m. And these are all from Kumpula station, which is right next to us. And as I said, we have 92 days from 1st of June to end of August. And we have 92 rows of data in our data set. So let's start by importing our library. Like I said last week, when you're working with external libraries, you have to start by importing them so they're accessible to you. You might also remember that when importing libraries in Python, you can give them a nickname. And with pandas, it's very common to give a nickname PD. So if you're accessing a function, you don't have to say pandas dot something. You just say PD dot. So it makes typing a bit shorter. So let's import the library. So now pandas is available to us, and we can use the functions that are available within the functions that come with the package. So I'm going to load my data now, and you have to store your data in a variable. So before we have used variables to store values in, or lists, or different things, you can also store data under a variable, or use a variable to refer to that data. So there's a function coming with pandas called readCSV. So this is the function you will be using for importing CSV data. You can provide a number of inputs that we will see later, but the bare minimum is that you provide the path to your file. So either the path or the name of the file if it happens to be in the same directory. Ours is not in the same directory, it's under data. And the name of the data set was Kumpula-summer-2024, if I'm not mistaken. And remember to put the extension of the file as well. It was a TXT file. So even if it's CSV format, the file itself was TXT. Okay, so now let's run this. The data was imported right away. It's not a very large data set. So we already checked out the data, and it is comma separated, so it's fine. But remember that, as I mentioned, you can get data sets from other sources in which, instead of comma, something else has been used. For example, it's common to see a data set that has been separated with semicolons. Yeah, this is common. For example, it's like depends on the field, but also the country. For instance, in Finland, you know, that for separating decimals, we use comma. So it can be that to avoid confusion, some data provider might not use comma to separate the values, so it doesn't get mixed with the decimals. Yeah, so if you just open your data or check the documentation, you see that, and if that's the case, so if you do not say anything, if you just import the data, it assumes that it's comma separated, so you don't have to specify. But if it happens to be separated with something else, you have to pass in a variable called sep, and there you can provide whatever sign has been used to separate the values from each other. So we are going to see that later on, but remember that here, because we had comma, we didn't have to provide anything else, but if our data had used another kind of separator, for example, a semicolon, then I would have provided it as input here. But that's not the case now. I just remove this. Yeah, so you can always check the documentation to see what other parameters you can provide to the function. And also remember, we saw last week you can use help, name of the function, and then you get some help printed out to your screen as well. There are other functions working very similar way, like for example, pd.readPickle. So if you're importing pickle data coming in pickle format, there's a function for that. If you're importing data coming in Excel format, there's a function called read_Excel. So they work very similarly, but for different formats, they have different functions. Okay, so now let's look at one of the most used functions in pandas, and we are going to use that a lot, and that's called heads. It's actually a method. So data.heads. We are going to use that quite a lot. So what this does is it gives you a preview of the first 5 rows of your data. So if you just want to know, okay, I just imported the data and I want to see whether everything is in order. You can use data. Data is the variable under which you have stored the data, and .head. If you do not provide any inputs for the function, it's going to print out the first 5 rows of your data. But if you want more or less, you can specify. So if I put 10, it's going to give me the first 10 rows of my data. So this is something we will be using over and over to just look at our data before we continue, which is a good habit. So there is something wrong with data. If you remember, which you probably do, in our data sets, we had some metadata at the beginning. So as I said, computers are smart, but you have to give them instructions. So without instruction, pandas doesn't know that data starts from here. So it's going to read everything, treat all of this as data, which is not the case. So we have to find a way to skip those. But before we do that, let's also look at another useful function in pandas, and that's called tail. As you can guess from the name, it shows you the very end of the data. So with head, you get the first 5 rows. With tail, you get the last 5 rows. So the last 5 rows look fine. And similar to what we saw earlier, with head, you can provide an input. So if you want to see the last 10 rows, you can put 10 there or any other number you want. Okay, so now let's fix the problem with the metadata loaded as data. So I go back to our data to take a look. I want to skip the rows. So I want to tell pandas, when you're importing the data, skip this number of rows. And I'm going to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm also counting the spaces because it's also a line. So now I'm going to import the data again, and this time I'm going to tell pandas that skip the first 9 rows and start importing from here. And this is how you can do it. There is a parameter that you can provide to the function. So I'm going to import the data again. It will be overwritten in the data. Same function, read CSV. I'm going to again provide the path to my data, which was under data, Kumpula, summer 2024, and the extension was txt. And this is the new variable parameter that I'm adding to my function. It's called skip rows. And then you tell that, okay, skip 8 rows. Your data starts on line 9, so it skips the first 8 rows, and then it starts importing the data. So now that we did this, let's take a look at our data, again using head. And now it looks fine. So it skipped the metadata, started importing from line 9, and everything looks fine. Let's also look at the very end of our data to see if it has been imported properly all the way to the end, and it looks fine toward the end as well. As you can see, we have 92 rows of data. So the highest index value is 91. Remember, it starts from 0. So we have 92 values, which corresponds with the 92 days in summer from 1st of June to end of August. Okay, so now that the data has been loaded properly, let's continue. Yeah, so same thing that I showed you at the beginning, the data structure, you can clearly see it here. So this is the index column that doesn't have a label, but it's the index created by pandas. We have the rows here, we have the columns, and each column has a label. And here we have the values. You have some missing values, and we are going to deal with them later, but it's showing NaN, like not a number. So it's a missing value or a null value. So there has been missing information in your data. So the device, for example, in Kumpula has been broken and hasn't recorded the temperature in one of the days. So that's very often the case. When you get your data from somewhere, it's hardly ever perfect. There are some missing values or errors. But we will learn how to deal with them later on. Okay, now let's take 2 minutes and try something. Now we want to import the data again, but not the whole data. We want to just import part of the data, so just a number of columns. So how would you read the Kumpula data in once again, selecting only the columns year, moda, and temp1. Try reading the file into the new variable temp data by only selecting these two. So let's just take 2 minutes to try this. Of course, we haven't looked at it before, so you can open the documentation from here and see if you can figure out. So these are the parameters that you can provide to the function. So here you can see that there are a lot of parameters you can provide as input. That's why no one would remember this unless you use them all the time. So it's good to check out the documentation. For example, we used already the skip rows. There's also a function the parameter to skip the footer. There is one to skip the blank lines. If your data is messy and has some blank lines in between, there is a parameter you can set so it skips the blank lines. But yeah, there's so much. So I start doing this at the same time. You can continue. So there's one parameter that we are going to use, and it's called use calls, so short for use columns. And I'm going to provide a list of columns that I want to use for importing. So not to overwrite the original data that we previously imported, I'm going to create a new variable, temp data. And from PD, I'm going to use the same function called read_CSV. I don't want the line to get overly long, so I will go to a new line. Remember, from one of the good coding practices, this was possible in Python. So again, I'm going to provide the path to my data, Kumpula summer 2024.txt. Remember that we still are working with the same data, so I'm going to skip rows containing the metadata. So skipping the first 8 rows. And this is the new part. So I can tell pandas that only use these columns. And it has to be a list. Remember, a Python list. So you can specify as many columns as you want, as long as it's put into a list. So year moda is one of the columns I want to use. And the other one is temp1. Then I'm going to also look at my data to make sure it was imported properly. And remember, for doing that, we can use head. Okay, so now we imported our data, but this time we included only 2 columns. So remember, there is a parameter called use calls, short for use columns, and there you can provide a list of the name of the columns that you want to include when importing the data. Okay, so now we learned how to import data. Exporting data is also as simple. So I'm going to export our data to a file, and the name is already typed in. So output file path is Kumpula temp result summer 2024, and you can choose what extension you want. I export it as a CSV. So I go with .csv. And of course, you could have provided a full path. So if you wanted to save it under data, you could have put data / then the name of the file. But now I'm going to just save it in the root folder here. So how do we save a file? There is a function for that. So data is what I'm trying to save to CSV. So again, there are different functions for exporting to different formats. But now we want to export as CSV. You have to provide the path to the data, which we have already stored under output FB. Another thing you have to specify is the separator you want to use. Remember that you can use different separators. I'm going to go with the most common one, which is a comma. So let's run this. So you can immediately see that the data file was created here in the root folder, if that's what you have used. I open it and you can see you just exported your data. And we import it as a CSV, so we see it more nicely visualized here because the extension is CSV and Jupyter Lab can recognize it easily. So here it was a TXT file. You just see it as a raw text file. Here it's a .csv file, so it's formatted a bit. But it's essentially the same thing. So these are data, and you can also edit this is a function coming with Jupyter Lab. It's the environment we are using, that you can choose the delimiter. But I'm happy with this. I don't want to change it. That's the delimiter we have used. Yeah, so that's how we can save data. There are also, if you check documentations, again, there's a link here. You can see some of the parameters that you can provide when exporting your data. And now I'm going to try one of them. So if you look at here, the index column that Panda had created was written out to the output. So we have the index here. If you don't want that to be included, you can set it to, you can turn it off. So let's see what we can do. So I'm going to export data again to a CSV file. So I'm saving it in a new place or under a new name, so I don't overwrite what I had written before. So it's called output _ FP2. Again, I use commas as the separator. So if you don't want the index to be written out to the output file, you can set index to false. Another thing I want to do is that I don't want decimals. So you can see in the temperatures we have decimals. We already saw this in the first week or second week, that you can format the output. So I'm going to set float _ format, which is another parameter you can provide. And this is going to tell Python that, or pandas, that we don't want any decimals, so 0 float. So float without any decimals. So now if you open the new file, so the index column is no longer there, and the values are integers now. So we got rid of the decimals. So again, there are a lot of parameters that you can use when writing out the file, that you can check documentation and see which one might be useful for you. Okay, so now we know how to read files in pandas, how to write the output. Now let's explore a few other things that we can do to explore our data. One useful thing is to check the length of our data, or the number of rows, and this is similar to what we have seen with lists. So using a function called len, you can check how many rows of data you have. So we have 92 data sets, and 92 rows of data in our data set. There is another method that you can use. It gives you the shape of the data. So it gives you the rows and columns, the number of rows and columns. So it's telling you that your data has 92 rows. So the first one is row number, or number of rows. Second one is number of columns in your data. So you might recognize this format. Do you know what this is? What is the output? It's a tuple. Yeah, it's a tuple. So we have seen tuples. So if you want to access these, you just use the index value. So if you store this under a variable called a or whatever, then this is index 0, this is index 1. So if you need to access it, it's a tuple, and you can access the values, individual values, using the index value. If you want to get a list of the columns that are available in your data, you can use data.columns.values. And this is going to give you a list of the columns that you have in your data. So these are useful things. Remember that you don't want to always import your data or open your data. It might be somewhere remote, or you have large data, or you want to automate things. So these are ways that you can use to access the name of your columns. There is also a method that you can use to check information about the index. So if you use data.index, it will give you some information about the index. As I said, index in pandas is flexible, so you can change it. It doesn't have to be integer. So this can be useful. So in this case, it starts from 0, it stops at 92, and we have steps of 1 in our index. If you want to check what kind of data types you have in your data, you can use data.dtypes. It's going to give you a list of your columns with the kind of value that is stored in each of them. Oh, no. Yeah, so data.dtypes, you can do that. So now let's take 1 minute and print out the number of columns in your data. So you already learned how to get the list of columns. Remember, you can count the number of items in a list. So how do we get the count of columns using this approach? So data.columns is going to data.columns is going to give you a list of the columns, and if I use len before it, I can count the number of columns. So this is another way you can get the count. So you saw the shape, here's this one way, this is another way, and there are a few other ways that we will see later on. Okay, so selecting columns. You already saw that when you're importing your data, you have the option of just including some of the columns and exclude some of them. But sometimes you have the full data set and you want to just select one column to work with, or you just want to make a sub-selection of your data. So that's a common thing we do with our data sets. So let's make a selection of our data, and I'm going to store this selection under a variable conveniently named selection. It will be a sub-selection of my data. So this is how you can provide the name of the column that you want to be included in your selection. So here I can put year moda, or temp1, or temp2. But if you want to include more than one variable, more than one column, you have to provide a list. So that's why you see these double square brackets. So it's often a source of confusion. So this works fine, just one, if you want to just say year moda. But it only takes one input. So if you want to choose more than one column, then you have to pass it in as a list. That's why you see these double square brackets. It's very often we forget and get errors. So I'm going to select two columns. That's why I'm using a list. I'm using year moda, which contains the date information, and then max, which has the maximum temperature of the day. And to make sure this worked fine, I'm going to print the head of my selection data. I have a typo here. Okay, so now I made a sub-selection from my data only containing two of the columns, year moda and max. One thing we didn't do before, but you can try on the data, is to check the type of data. So type, which we have seen already many times during last week, selection. So you can see that this is a pandas data frame. So the selection itself becomes a new data frame. But imagine a case that you just exported just one column. Then it would be one-dimensional. It would have become a data series. But now you have two columns and you have many rows, so it's two-dimensional. It became a data frame. So pandas automatically recognizes that is this a series or a data frame, depending on number of columns and rows. So you can try the same things here as well. So if you want to see the shape of your selection data, so you can use .shape. It has only two columns now, but same 92 rows. Another useful thing is that if you want to, well, we have used the head to look at the all of the columns. But if you want to specifically look at the first 5 values from a certain column, of course you can just provide it here. So I'm only looking at data max, the column max, and I'm only looking at the head of that column. So this is only going to return the top 5 values from this column. So what essentially I'm doing here is I'm making a selection without saving it into a variable like we did up here. So I'm making a selection without storing it anywhere. I could have stored it under a new variable. So to prove what I just said, I can check the type. And you can see it's a pandas series. So like I said, because I've only selected one column, I ended up with only one dimensional data, so it automatically becomes a series. if I had max and year moda, like in the earlier example, it would have become a data frame. So the definitions are very dynamic, so it recognizes it like automatically. So now we are covering a number of like random functions and like methods that are useful. You will later on need them for your work. So that's why we are not following a clear agenda yet in this part. Let's look at another method that comes with pandas data frames, and that's unique. So if you want to get a list of unique values in your data, because very often you have repetition, you can use unique like this. So I want to see the unique maximum values, or the unique values in the column max. And it returns me a list of unique values. Some of them might have been repeated in the data multiple times, but these are the unique values. If you want to get the number of unique values in your data, now there is a list. Of course, you can count the number of items in the list, but also there is a different method for that as well. So let's use that within a print f string. So I'm going to write there are, or there were data. This is the column I was looking at, max. And the new method is called nUnique. So it's number of unique values. So the only difference is one n at the beginning. Can you see what I've done wrong here? Yeah, I'm missing something here, I don't see. But anyway, you can use this nUnique to get the number of this. So the other way to do this would have been to use len. So if you store this somewhere, then you can get the count. Yeah. So the error was that I had used double quotation, and because I'm using, someone had noticed, because I'm using double quotation here, it just got confused. But yeah, that's a good point to remember. Another useful thing you can do with pandas is to get the descriptive statistics fairly easily without using any other statistical libraries to calculate things. So I'm going to use, again, the same column. So using mean, I can get the mean value of this column. And it's going to return a numpy float. Doesn't matter. It's just a float, 22.04. So these are traces of you can see this is coming from NumPy. As I said, pandas is using other libraries. So it's returning a NumPy float. It doesn't matter, you can just use the value. But yeah, you see such traces because it's using other libraries. So this was just applied on one column. What if I apply it to my whole data? So it's going to calculate it for all of my columns individually. So for year mode, of course, it doesn't make sense because it's the date, but it's a number, so Python doesn't know. The max, mean, temp1, temp2, for each of them, the mean value is calculated. If you want to quickly get the descriptive statistics of all your columns calculated, you can just use data.describe. And it's going to calculate some basic statistics for you. So it gives you an overview of what you have in your data. So by default, and there are ways of, like if you check the documentation, you can control the output. But by default, it's going to give you the count, the average, the standard deviation, minimum, and the quantiles, and the maximum value. So this is also a useful feature that you can use to quickly get an overview of what you have in your data. So now let's spend 30 seconds and get the descriptive statistics for only few columns. So now we got it for the whole data. Now try to get it only for these 4 columns, for temp1, temp2, max, mean. You should have the skills already to do this. So we already saw that it's easy to make a selection from our data. The only thing you need to do is to provide a list of name of the columns that you want to include. So I want temp1 to be included, temp2, max, and mean. And remember that you're providing a list of columns, so that's why you end up with these double square brackets. And then dot describe. So this is very simple. What we are basically doing is making a selection without storing it anywhere. You could have stored it, then use .describe, and then get the description for it. There is another method built in the pandas data frame and series, and that's called .info. It gives you some general information about your data. So let's try and see what we get as the output, data.info. So it gives you a bunch of information. Okay, how many rows do you have? What are your columns? What kind of data you have? How many missing values you have in different columns? So you can see in some of the columns we have some missing values. So in max we have only 82 non-null values. So it means that we have 10 missing values, and we are going to deal with them in the next part of the lesson. Okay, this is the part that everything is typed in. I'm not going to go through it, but we take a very quick look, and that's constructing pandas objects. So now we are very often we get our data set from somewhere and we want to use it, but sometimes you might want to create your own data set. So you have some values, you want to change them into a pandas data frame and do your analysis. So that's also a possible scenario. Like we do it quite a lot in world of GIS. You have coordinates, you want to create a pandas geodata frame that you can just visualize. So we do it quite a lot in GIS, but data analysis, you often get your data from somewhere. But yeah, it's fairly easy. So if you have a list of numbers, a Python list, something we have seen many times, you can easily convert it to a pandas series. So you just provide the list and use pandas, pd.series. It will be converted to a pandas series. If you have two-dimensional data, meaning that you want to create, so let's run this and see the output. So now you have a pandas series. If you have two-dimensional data, you have number list, then you have index list, two separate lists, and you want to use it as index. Like I said, index doesn't have to be integers necessarily. So here the index is A, B, C, D. And we are going to work with that next week. But yeah, it's still a pandas series, but this time you have used different values for indexing. Here is an example from the GIS world. So we have stations with the coordinates. Here we just convert it to a data frame, but later on we will see how to make a geodata frame so we can do GIS on it, but now that's not what we are doing in this course. So let's just run this to load the values. So similarly, if you have multiple dimensions, you can, instead of pandas series, you can use pandas data frame. And then you provide the inputs to your data, and you end up with a pandas data frame. You can also do this with dictionaries, and this is something we will do a lot in GIS. Now we just skip for now. We haven't worked with dictionaries yet. We will do that later. But yeah, you can look at this later on, but if you need to create your own data frames for whatever reason, if you're working with GIS, you're creating new vector data, or if you are just creating your own data, you can manually do that as well. But very often we just import our data which has been taken from somewhere else. Maybe now it's a good time to take a break before we continue to the second part, which is actually a bit bigger than this first part. So let's take a 10-minute break and come back here fresh and continue. So we continue at 10:25. Okay, let's continue so we don't run over time. Yeah. So in the first part, we learned about pandas, and what we haven't done, well, we have been exploring the data, but what we haven't done so far is that we haven't changed really anything in our data. Have we created a new column? No. Have we calculated something? Not really. And that's what we are going to do in the second part. We will learn how to actually analyze the data and make changes to data, calculate things, so things get more interesting. Yeah, before we continue, a couple of things. Like there's a lot of information coming in now, and it's very normal that you wouldn't remember everything. So people who are new to pandas for a long time, you still need to go back to documentation to remember, okay, how do I do this? So that's very normal, and this is the week that usually we get a lot of students going to the help sessions on Thursday and Friday. So if you run into issues, remember that we are there to help you on Thursday and Friday, and of course on Discord. Okay, so common tabular operations in pandas. Now we want to see how we can make edits, calculations using pandas data frames and series. So we start with some very basic calculations. We are working still with the same data on the summer temperatures from 2024. So let's just start fresh. Let's import our data. So I'm going to separately define the path to my file, which is a good habit if you want to make your code easily reusable. And it was called Kumpula-summer-2024, and it was a TXT file. Next thing I'm going to do is to import the data. We have done that a few times already. As we remember that we need to provide the path to the file. And it's the same data we are working with. Remember to skip rows, first 8 rows. Okay, now the data is loaded. As a good habit, let's just start by looking at our data to see everything is fine. And it does look fine. Okay, so the first thing I'm going to do is to calculate a new column. That's something we haven't done yet. So I'm going to create a new column called diff, short for different, and I'm going to later on calculate some temperature differences there. But this is how you create a new column in pandas, and it is very easy. So what you do, name of your data variable, this is the name of new column, and you have to apply a default value to it. Of course, you are going to override this later. We calculate something, but just put a placeholder to create the column. To make sure this is done, oh, I forgot to put diff in quotation mark, of course. It's the name of the column. And then I put data.head to make sure that the column was added successfully. Yeah, so it was done. So creating a column is very easy. This is how you do it. I created a new column called diff. For now, I've just put 0.0 as placeholder, but later on I'm going to calculate things and populate the values into the table. I want to check the data format for this column, and remember we have done this already today. So this is how you do it. I want to just check it for this column specifically, and there was a method for that called dtypes. And it's going to tell me that it's a float, which is not surprising. I had put 0.0, so it had decimals. It's recognized as a float. And this is where I'm doing the calculation. So we have already created the column. Now I'm going to calculate something. So I'm going to calculate the temperature difference, and I will define it as difference between max and minimum temperatures to get the range of fluctuations for the day. So this is the variable, the column in which these values will be stored. And this is the mathematical part of it. So I'm just going to subtract data max from data minimum. So this could be any mathematical operation that you need for your calculation. And once I do that, I will look at my data again to make sure it is done properly. Okay, so now you can see the values got updated in the diff column. So it's the subtracting max from mean, and this is what you end up with. So calculating something in a new column is very easy. This was just simple mathematics. It can be something more complicated. You can use a function to calculate something. And we are going to see those examples in next week. So in the first example, what we just did was that we created a column, we put some placeholder for the value, then we recalculated the values. You can, of course, do this on the go. You don't have to do it separately. So I'm going to create a new column now, and that will be called temp. And I will define it as the average value between temp1 and temp2. So let's create the new column, and this is how we do it. We have already seen this. It's a new column called temp. And then here you have to do your calculation. So this is how I'm going to calculate it. So it's data temp1 plus data temp2 divided by 2. Remember that I'm calculating the average here, so this is how you get the average. And then I try data.head to see how it goes. So now I ended up with yet another new column called temp with the average values that are calculated based on temp1 and temp2. So this is a very, all of you have worked with data before. This is one of the things you will be doing a lot when doing data analysis. You have some columns, you create a new column, you calculate something based on your existing values. Okay, so now let's take a minute and try something. So create a new column called temp Kelvin, and you already know how to convert Celsius to Kelvin. You just add 273.15. So let's do that now. Create a new column called temp underscore Kelvin and convert the temperature, the column we just calculated, convert it to Kelvin. Okay, so how many of you got it right? Raise your hand. Okay, many. Okay, so I will do it here as well. Here you provide the name for your new column. I'm going with the temp Kelvin. And then here is where you do the math. I'm going to calculate it based on the column temp. And what I'm doing is basically adding temp 273 to temp 3.15. Now, of course, if you want to confirm that this is done right, you already know well that you can use data.head. And you can see a new column is created, temp Kelvin, in which we have a stored temperature in Kelvin. Okay, so now we know, yeah. Column. We are going to look at that, so yeah. Yeah, we are going to look at deleting, but for now, if you just want to do it, you can just make a new selection. Just select the columns that you have. Okay, so now we are making a selection based on rows and columns. And that's something that we often do. So you have some condition, you want to select the rows. For example, now we have 92 days. You want to choose the days that are hot, and you define hot by a certain temperature. So you want to choose the days select the days that have a temperature of more than a certain degree. So that's one way of choosing, selecting based on some condition. You may also want to select a portion of your data from somewhere. So you want to choose the first 5 rows and continue with those. So there are a few ways how you can do that. So the first kind of selection is using the index value, and this is very similar to what we have done before with lists. So selection, data, and remember we used to do this with lists in Python, so I'm going to make a selection of my data, only keeping rows from 0 to 5. And I'm going to print it to the screen to make sure it is done right. I have a typo here. Yeah, so we made a selection of our data, only keeping the values that are between up to index 5. So this is very similar to what we have done with list. You can also specify the stop index and also the step. So remember we did that with range and lists. So you can say from index 1 to 20 with the steps of 5 or 2. So that's how you do it. So you just put a column in between, start, stop. You can add another column here and then add a step. You can put 5, 10, 2. So it's like from 5 to 2 with the steps of 2. From 5 to 10 with the steps of 2. But if you don't provide a step by default, it just goes one by one. So this is one way of doing this, but it's rarely the case because now you're working with real data, so you rarely need to make selection just randomly like that, unless you want to make a random selection of your data. Even for that, there are better ways. But it's good to know that that's one way how you can select your data, select from your data. But there's, as I said, there's a better way and more flexible way of selecting data using pandas.loc. So there's a method defined on data frames that called loc, short for locating. And it allows you, as the name suggests, it selects based on access labels, row and column names. So let's see how this works. It's always easier to see in practice. So I'm going to make a new selection of my data. But this time I'm going to go with this data.loc. So this is something we will be using a lot when working with pandas. So again, I'm providing the index range that I want to keep in my selection. But an additional thing you can do here in loc is that you can provide the columns for which you want to do the selection. So I'm going to do the selection based on temp column. And to make sure this is done properly, I'm going to just print it out to the screen. So now you can see I made a selection of my data for just based on one column with values, index values up to 5. So one thing that is source of confusion here is just how this works. So when you are using this direct method, you're working with the index value. So it works very similar to how the lists work. So if you provide 5, it's going to go from 0 to 4. So it's n minus 1. But loc works differently. So it's not really looking at the index, but the number of the rows. So if you put 5, it's going to give you up to row 5. So you actually end up with 6. rows. So just remember that with loc it works differently. So now actually this is the recommended way of selecting. So using pandas. So use loc instead of the original, and just get used to it that this is what you get. So if you put 5, it's inclusive of index 5. Yeah, so this is how it works in practice. So it's still using the index values, but it's treating them as the labels for the rows. So if you're using loc and providing 2 values, first include the label last. So it's inclusive of the last value. And of course, you can provide the columns. So by looking at the syntax, you might imagine that it's possible to select multiple columns using loc. Let's test this and see how it works if we can select 2 columns at the same time. Now I'm going to overwrite the selection, data.loc, and I'm going to go 0 to 5 again. But this time I'm providing more than 1 column. And remember, when we are using more than 1 column, you have to pass it in as a list. So it's a list of my column names that I want to be included. So it's the temp and temp Kelvin. So that's possible. So with loc, you can provide as many columns as you want to be included in the selection. So you remember from the first part of our lesson before the break, we learned a way how to calculate average values from a column. So now take a minute or 2 and try to get the average values of temperature between rows 85 and 91. So last 7 days of summer. So make a selection. Select the last 7 days of summer, which would be from 85 to 91 index value, and get the mean, the average for it. So let's spend a minute to see if we can do this. Okay, so I do this here at the same time. So I'm making a selection from my data using data.loc. The hardest part, which I already revealed, was figuring out what is this last 7 days. But the index goes up to 91, so the last 7 days will be from 85 to 91. And I wanted this for the column temperature. So the only thing you have to do is to apply .mean. Because what this returns is another data frame, and then we saw in the first part that you can use .mean on any data frame to get the minimum, to get the average values. So if you just run this, you can see that the average value, summer temperature last week of August in 2024 was 19.6. Okay, so now we saw how we can select based on like select a range of values. How about selecting a single row or a value? You can also select an individual row from a specific position using lock indexing. Here we select all the data values using index 4, which will be the 5th row in our data. So if you want to do that, you can just select the row. So I'm going to store it under row with data.lock. I'm going to select row number 4. And then I'm going to put it here. Yeah. So if you don't want to go with the range, you can just directly access a certain row in your data using the index value. So as you can see, what you get here is actually a pandas series, because now it became a one-dimensional data set. So it's just one row of your data, and as I said, each row or column of a data frame, if you look at them individually in pandas, becomes a series. So if you want to just, now it's a row, if you want to get the temperature value of one certain column from that row, of course you can just provide the name of the column. So for that row, I want to see what the temperature is, and you can easily do that by providing the name of the column. To make this shorter, if you just want to get the value exactly to a certain point, so now we took 2 steps. I selected the row. From row, I check the value of the temperature. If you just want to do it quickly, there is also a method for that. So I can use selection.at, and it gives you a specific value. So from row 0, I want to see the temperature value. So this just makes it shorter. With one line of code, you will get the value at a certain location. So these are very similar. So with lock and add, you can basically get the same thing. Just remember, with the lock, you have the option of getting a range. With add, you always get one single value. So lock is more flexible. So generally, we go with lock, but add is very efficient. So that's one of the reasons. So if you're working with a huge data and you want to just access one single value, add is faster. So if efficiency is something that is important to you, then we can use at. But otherwise, we can achieve the same goal using lock like this. So selection.lock, and I'm going to access row 0 and read the value under temp. So I get the same output. So you can use at or lock. Lock is a bit more flexible. You can get a range. At it gives you only one value. But add is a bit more computationally efficient, if that matters to you. Okay, so there's one optional part that I will quickly tell you about, but the code is typed in, so we don't do anything here. We don't type anything here. So there's a version of lock called ilock that works based on the index position. So we have learned so far that with lock and add, the lock and add are based on the access labels. So remember, it includes also the end. But with ilock, we are working essentially with the index value. So print, let's look at what we have here. So we are checking the first rows of our data, printing the head of the data, the first 5 rows. Yeah, so with ilock, you're working with indices. So here, look, you're not providing the name of the columns. It also uses indices for the column names. So if the column was called temperature, here you're not using the temperature anymore. You're just using index 0, which is the first column in your data. So the same logic applies here. So 0, 1, 2, 3, 4, 5. So iLoc is working with indices. So that's why it's optional, because we can achieve the same thing with the column name. But if your program somehow works in a way that it's easier to work with index values to automate something, then there is the option available to you. But generally, this is optional, so we prefer to go with the loc, which nicely works with the label names to keep our life easy. So you can just use data iLoc to get the value from row 1 from the second column in your data. So the same thing also applies, and of course you can also use ranges. So a range of rows, a range of columns. The same thing also exists for @. So there's also a version of @, which works using the index values. Okay, so now moving on to the next part, which is more important, and that is selection based on a criteria. That's something that we very often do. So you have a big data set, you want to select based on some condition that you define. So values within a certain range or values equaling a certain number. So now we start with a simple example. Well, remember that in our data we had a column called year moda. So year 2024, mo is like the month, 06, so it's June, and da is day. So that's the structure of that column. So I want to select only certain days in my data. So I have a selection criteria, which is a list of the dates that I want to select. So I want data from 1st of June, 8th of July, and 9th of August. Just some random dates to try with. So you can provide this condition. When it's making a selection with loc, as I said, loc is very flexible. So I can use data.loc. And then the column based on which you're doing the selection, and the column I'm using is year moda. And this is how you check the conditions. So there's a method called isIn. So is the value in the given selection criteria? And here I provide the selection criteria that I defined earlier. So this goes row by row, looks at the values in year moda, and it checks if that value for the given row is within this list or not. Typo from where? Yeah, it was criterion. Yeah, so we made a selection, just 3 rows corresponding with these dates. So this is a useful way of making selections if you want to go with certain values. Conditional selection. This is another kind of selection that we do often. So what if we want to choose all the rows that have a temperature, a max temperature of 25 degrees? So we already have seen conditional statements in week 2 or 3, and we know how it works. So if you just apply a condition like this on a column, this is what you get. So it just checks if each row, and it tells you whether the condition is met or not. So in first column, true, so the temperature, the maximum temperature that day was more than 25. In the second row, it's false, so temperature was less than 25. So this is what it does. So basically, we can use the same logic now to make our selection, because here we haven't made any selection. It just flags the values. But if you want to make a selection, then this is how we do it. So we are going to make a new variable, and I'm going to call it hot temps. So days with hot temperatures. And I'm going to use data.log. And the column I'm looking at is max. And this is where you apply the conditions. So I want to pick the days that are 25 or even hotter. So here you just flag the values, but here you can just make a new selection. So I'm using log to make the selection, then I'm saving the output in a new variable called hot temps. Hot, then I take a look at the hot temps. So it made a selection of my data. So these are the hot dates. So we ended up with how many? Like maybe 10 rows. So there were 10 days, for example, in summer 2024, where we had a maximum temperature of over 25. It's also possible to combine multiple criteria at the same time. So if you have, for example, one column with rain amount, you can choose days that have been rainy and warmer than a certain temperature. So you can have multiple conditions. So now we're going to apply a condition based on the date and the temperature. And this is how you can do it. So I'm going to make a new variable called warm days, or warm temps, actually. Again, I'm going to use data.log. So this is my first condition. I want to make sure that the temperature is more than 20 degrees. So that's the first condition. And my second condition is that the date should be after a certain time. So I'm going to select or access the column year moda. And my condition is that it is sometime after 15th of July. So I'm looking for warm days after mid-July. And let's print the output. Yeah, one parenthesis closing. So now I made a selection based on two criteria, or a criteria that had two parts, and that was date after mid-July and the temperature over 20. And I ended up with some rows in my data. Okay, so I've done the selection, and I've ended up with 27 days that have been hot enough. Have met our criteria. So it's after July, and they have been over 20 degrees Celsius. Now that we have a subset of our data frame, with only rows where temperature is above 20 and our dates year model column start with 15th of July. That's what we have done. So one thing that happens is that when you're creating a new selection, it does not automatically reset the index values. So now you have ended up with a new data frame, but the index values are the index values of the original data. And that can be confusing. Sometimes you just want to keep it like that so you can always like join or match it with the original data. But sometimes it's confusing because you want to make a new selection and your data is starting from index 44. So there is a way to reset the index. And this is how you do it. So warm temps equals warm underscore temps dot reset index. So here you can optionally pass in a variable parameter called drop true or false. By default, it's false. So what it does, when you reset the index, it keeps the old index as a column in your data. So it wants to keep track of what the data was like. I don't want to keep that, so I've set drop to true. If you want to keep that, you can try it. You can just set it to false, or just remove that, because by default, it is false. So if you set drop to true, you're telling Python or pandas that I do not need to keep any record of the old index values. Just drop it, index the create new index for me. So now that I run this, you can see a new index is created. So it's starting from 0. So note, if this was set to false, it would have kept a track of the old index values. Now I ran it once, so the old index value was gone. But this is what would have happened. It would have kept track of the old index value, which can be useful. As I said, you want to keep record of the original data. Does it make sense so far? These things take time to get used to, of course, but they're not difficult. So one thing that happens in Python, in pandas, and can be useful but very often actually confusing, is that sometimes when you make a selection from your data, the data stays linked. So you haven't really created a new data frame, but you have a selection from the original one. So what happens if you make a change to the original ones, the values, it will also get updated in your selection. If you just want to treat it as a separate data without any confusion, just do the reset index. So when you reset the index, it actually becomes a new data frame. So just to be sure that you're not working with a view, you're actually working with a new data frame, just reset the index. And that will end you up with a new data frame, then you're safe. So let's see what this actually means in practice. So I'm going to make a new selection now. So warm underscore temps. Again, I'm going to use data.log. And now I'm going to provide the criteria for my selection. So similar criteria. I want the temperature to be over 20. And I want the day to be after mid-July. 24/07/15. And from those warm days, I'm going to make a selection. So let's go with warm underscore temps. Yeah, so let's create the new column, and I'm going to call it the hot temperature. And I'm checking, as the value, I'm checking the condition to see if the temperature is over 25 or not. So now we have made a selection of warm days. We are going to add a new column, and there we flag whether the day is actually a hot day or not. So for that, I'm checking whether the temperature, the max temperature, is over 25 or not. Warm temps. Okay, so this is what I wanted to actually show you. That you get a warning, and this is the warning. Setting with copy warning. A value is trying to be set on a copy of a slice from a data frame. So like I said, when you make a selection, you're not actually creating a new data frame. You're making a view. And then if you're adding a value to that view, it gives you a warning. So it doesn't affect anything. It just it still does the calculation, but it just throws you a warning that, okay, you're working on a view, not a data frame, so your data may not be safe. So in this case, we have created a new column using the selection, which is a slice from the original data. As a result, pandas raises a warning about a possible invalid value assignment. In most cases, this warning can be ignored, but it is a good practice to always make a copy. So that's why, to make sure that you have a data frame, you should either reset the index or make a copy of your data. And when you make a copy, then it's a data frame. So this is how you make a copy. So I'm going to copy this line so I don't have to type it again. The selection with everything. The thing I'm going to add at the end is dot copy. So what this does, it makes sure that you end up with a new data frame, not a view of your data. So now if I do this calculation, I should not get that warning anymore. So I did the same thing. This time I made a copy, so it wasn't a slice of the original data anymore, and I didn't get the warning. So this is a good habit to have. So if you make a selection, either reset the index and start working with a new data frame, or just make a copy on the go without resetting the index, and then you're safe. Okay, so now let's try what we learned. We already know how to calculate the average values, and we know how to make a selection. So now let's calculate the mean temperature for the last 7 days of August. So use log to make a selection based on year moda, and then use .mean to get it. So let's spend a couple of minutes and try to do this. Okay, so did anyone get the output? What is the average temperature? Okay, let's find out. So I'm creating, so I'm doing a selection based on the column called temp. I will use loc to make my selection. Data, year, moda. Is greater than 25 or 20, 24, 20, 24, 0, 8, 25. And then what we do, we get the the average temperature from it. And it was 20.30. It's actually August, not July, so it has to be 8. So it was 19.67. Okay, so I already talked about this, so I will skip it, but you can try it later on your own. So there's a difference between a view and a copy. And we learned that, okay, a view is still linked with the original data, so if you make changes to the original data, the view might get updated as well. So just to be safe, make a copy. And here you can test. We have a little test that it shows you that these changes can happen. Like the changes can be transferred. So try this on your own later on, but for now let's move on to the next section. So I already mentioned, and we already saw in the data, that we had some missing values, and that's almost always the case. Your data is rarely perfect. So how do we handle those cases? So let's look at our data, the warm temperature data that we just created. So if you look at the data, you will see there are some values that are not a number. So you have some missing values. And if you are doing some analysis based on this will cause problems for you. So that's why you want to handle it the way you want. So if you want to, of course, you can visualize your data. You can just look at your data to see if you have missing values. But if you have a large data, there is a way to check if you have missing values. So from warm temps, I can check the column, for example, mean, and see if it has NaNs. So it has nones. So it's telling me that yes, you have missing values in your column mean. So you can test this for any of your columns in your data. And if you want to try it for different columns at the same time, then you can provide a list of columns. So for example, I could have done this way, so calls to check. And here you can provide a list of the columns that you want to check. Here I will just go with one, but you could have added more. Warm, temps, clean. So what I'm going to do now is to drop those cases where I have missing value, because I'm going to do some calculation later on that might mess up with my calculations. So I'm going with warm temps. So there is a method called drop NA. So it drops the null values. And you can specify from which subset. So I'm going to use the subset, well, the one I just created. So calls to check. So if you want to get rid of rows in which you have missing data, there is a method called drop_NA, and you can apply it on one or multiple columns at the same time to get rid of those rows. So now I just did it for one column, but you could have optionally done it with more columns at once. So now if I look at my data, in the column mean, there is no missing value anymore because those rows were dropped from my data frame using this method. So this was specifically for one column, but what if you want to just get rid of any row that has a missing value in any column? But that's a dangerous thing to do because you might end up with a very small data. If it just removes every row for which there is one missing value somewhere, then you might lose a lot of rows. So you want to be careful with that. But if you really need to do it and you're sure that this is the right thing to do in your case, then you can just apply drop_NA on the data as whole without providing a subset. So warm temps dot drop_NA, so without providing a subset. And then let's look at the output. So you can see the data actually became quite small. You lost a lot of values. So yeah, so with drop_NA, you can apply it to the whole data set, or optionally you can provide a subset of the columns to look at. But if you go with the whole data, just be careful because it just removes every row where there is a null value in it. And very often in real life analysis, you don't want to do that. Something that we might want to do alternatively is to replace the null value with some other value. And there are in different fields different good practices. For example, in the world of GIS, for example, in ArcGIS, at least in older versions, they did not handle the null values properly. So I remember that they used -9999 when there was a missing value. And I guess it might be still the case. So if that seems to be the way to go in your field, if it's a standard, you can use a method called fill_NA, and you can specify what value to put instead of missing value. Like I said in GIS world, this is a common value, -9999. So what happens in this case is that all the values with missing value have been replaced with this. So this might work some cases, but you have to be careful with it because you have to remember that you have put those values. Because if I now calculate the average temperature based on this column, I have this value. So this is going to mess up with my calculation because it's a number. And Python doesn't know its missing value. Yeah, but you might need to do that. So if you want to replace it with some other number or value, you can just use fill_NA and fill it with something. Sometimes you just want to fill it with another value. You just want to put 0 for some reason or some average value. Then you can do that as well. So as a result, now we have a data frame where all null values in the data frame are filled with the value of -9999. As was the case for the drop_NA function, you can fill values in selected columns. So you can also specify for which columns you want to do this. And this is usually more recommended, so you just don't blindly apply it to the whole data set. So with warm temps, so I will go with the column mean, warm temps, dot fill_NA. I will fill it with the same value. So So this is how you would do it just on one column. You're basically just rewriting the same column, this time refilling the values with something else. So that's a safer option. Okay, there are still a few things left before we finish. So data conversion. So there's a method for doing data conversion as well. We haven't looked at our data in a while, like as whole, so let's look at the column temp. Dot head. So I want to see what kind of values I have there. So I can see that, okay, I have floats, so I have temperatures, they have 2 decimals. What if I want to convert this to something else? I want to make it integer. So there is a method for doing that. So I can access that column, data temp. And this is the method that I can use as type. So this is the way to convert. So we saw this with variables. We had, like in the first 2 weeks, we did this kind of conversion. If you are doing it in pandas, this is the function to use, as type. And then as input, you provide the type you want. So I want to convert it to integer. And I will add head here to just look at my data. So this is not doing anything. I'm just looking at my data because I don't want to save it. So you can see that it dropped all the decimals. So we don't have decimals anymore. It's integer. And you can see it even tells you that it's an integer data format. Yeah, so if you just want to make it integer, this works fine. But if your idea of dropping the decimals is rounding the values, of course, this is not the best way because you're just removing decimals without thinking which value is like. Even if it's 2.9, if you drop the decimal, it rounds to 2, which is not the best way of rounding. So you probably want to round it to 3. So if the idea behind conversion was rounding, that was not the best way to do it. So you can round the values this way. So I will continue working with the same column data type dot round. So I will round it to the closest integer, and then I convert it to integer. So I first do a proper rounding. So if it is 2.9, it becomes 3.0. Then I get rid of the decimals. And then let's look at my data to see what I get as the output. And you see the values are a bit different. So it's rounded before being converted to integer. Okay, so that was about converting data types. Another thing we want to quickly look at is sorting the data. So that is something that we do very often. For example, if you're working with your data in Excel, very often you sort your data in different ways to get a view of how things work. And that is fairly easy to do in pandas. So I'm going to sort my data, and there's a method called sort values. And you pass a parameter called by. And here you specify what column you want to use for sorting. So I want to sort my rows based on the temperature value. So now the data is sorted. You can, if you look at the temp column, you see they are just ascending. But what if you want to order it sorted in a descending way? So you can do it just by passing in a different, another parameter. So I do the sorting now again. Data.sort values. So again, I'm sorting using the same column, which was temp. But what I'm doing differently this time is that I'm setting ascending, which is the default value, to false. So if you don't say anything by default, it goes ascending way. So from lower temperatures to higher temperatures. So if I set ascending to false, then it just reverses the order. Yeah, so you can see now it's ordered from the highest temperatures, 26.3, all the way down to lower temperatures, 14. Yeah, so you can easily sort your data, ascending or descending. There are also other things you can do. You can check the documentation. Yeah. Okay, so now that we are working with sorting, let's still look at one more thing. In some situations, you might need to sort values based on multiple columns. So you have multiple columns you want to use for sorting, and that is also possible when working with pandas. And this is sometimes referred to as multi-level sorting, something that you can also do, for example, in Excel. So you can do this by passing a list of column names to the biparameter. Well, let's see how we do this. So what we are doing now is we have the date, but we don't have the days of the week. So we want to add a column to our data and calculate the day of the week. Let's do that. So I have looked at calendar already, and I know the first day, 1st of June 2024, was a Saturday. So I'm going to, in order, Saturday, Sunday, Monday, applying it all to my data. So this is what I'm doing. So I created a list of days of the week, starting with Saturday, because 1st of June 2024 was a Saturday. And I'm just multiplying it, so 13 times this plus 1 day, because I had 92 days. So I want to get what day it is. So this is not related to sorting. I'm just calculating what day of the week it was. There are different ways of doing that. There are libraries for doing that, but I'm doing it manually. I just know that the first day was a Saturday, and I'm going to just repeat that many times. So I'm creating a list of the values and repeating this list 13 times plus 1 to get 92 days. And then I apply this to my data. So this is not the main point. The main point is the sorting that we will do in the next step. So now I will just add this weekday to my data. So I'm adding a new column called weekday, and I'm putting the values that I created, the list that I just created for all the days in my data. So now you can see we added a column to our data set called weekday, and we know that, okay, 2nd of June was a Sunday. So this is what we did. Now we are going to do a sorting. Now we have a column with the information about the weekday of each row. Next, we can test how to sort the values so that we order the data by weekday, and within each weekday, the temperatures are ascending order. So you order it by days of the week, and then the temperatures in an ascending order. And this is how we can do that. So with data, I do sorting. And remember that you could provide a parameter called by. And as I mentioned already, this can be a list. So you can sort by multiple columns in your data. So I'm going to sort it by weekday and then temperature. And then do you want it to be ascending or descending? I'm going to go with different values. So I want it to be ascending for weekday. So this is, if you have multiple values, this also should be a list, and the items in the list should be corresponding. So for weekday, I want to go with true. And for temperature, I want it to be descending. So does this make sense? So we are sorting. In the first example, we sorted by just one column, simple. In this example, we have two columns, weekday, which I've typed wrong, and temp. And for each of them, you can specify whether you wanted to sort it ascending or descending. So this is a list, and they should be matching. So weekday, ascending, temp, descending. Yeah, so this is what I get. So I get all the Fridays, for instance. So days of the weeks are next to each other because they have been sorted, and then the temperature is descending, for instance, here. And of course, the sorting based on days of the week is because of the letters, so where they are in alphabetically where they're located. Yeah, so the point here was that you can do the sorting for multiple columns at the same time. Okay, this is optional part. We are not going to do it, but optional doesn't mean that it's not important. It's actually something we do quite a lot. Again, especially if you're doing GIS. For those, how many of you have ever done GIS? Can you raise your hand? Well, many of you. So one thing that we do quite a lot in not only GIS, in working with data, is joining. So you have multiple data sets. You want to join them based on a column that is common between the two. And in Python, in pandas, you can also do that. One source of confusion for many of you who continue in the second course is the terminology. So in GIS, we are used to the term joining. So you join table A with table B. In pandas, this is called merge. And that confuses people because merging in GIS, in like software, in ArcGIS, QGIS is something else. But remember, in pandas, joining is called merge. So there is a method for merging your data sets. So now we have another data here that we never looked at today. And now we are going to use it for this part. The code is typed in, so I'm not going to type it. Just quickly go through it. So I'm going to load the data which has the rain information from the same summer, same days. So I'm going to load that data. This is what it looks like. So we have the date in the same format, and we have the amount of rain. And we already have our data, the data that we have been working with today. So what I'm going to do, I'm going to add the rain information to my data. This is how you do it. So this is your left data. So remember, if you have done GIS, you're joining your data A with something, but some other data. So I'm joining this rain information to my original data. So this is how I write it. Data.merge rainfall. So rainfall will be added to data. Then you have to provide the column that is used for joining. There should be a common column. If you don't provide anything, it means that you have a column that is common and named same way in the both data sets. So in that case, you don't need to provide anything. It just locates those columns that are the same. But if that's not the case, or if they have different names, for example, in the left data set, our original data, the date was stored as year moda. In the rain data set, the column is called date. So they don't have the same name. So pandas won't be able to do the merge or the join. So I'm saying that the column that will be used for joining in the left data set, which is data, is year moda. In the right column is called date. So remember, here the order matters. This is the left data, right data. What is the column in my left data is year moda, and the right one is date. So now the join is done. It's the same data. Now we also have the rain information added for each of the days. Yeah. So if you don't want to add everything, so in this data we only had 2 columns, so it's not a problem. But if you had a huge data and you don't want to overcrowd your original data set, you can also select some of the columns to be added. So if you just wanted to have date and the amount of rain, you could have passed it in as a column. Or you basically are making a selection, then doing the join. Yeah, and that was it. I know that was a lot of information and a lot of talking. hopefully it's not too confusing, and now you will be doing your next exercise and you will be working with these things, so you will get used to them. If you don't have any questions, then we can wrap it up here, and let's see each other next week.